Hello everyone, I am Ying. Today I'm going to discuss about gravitational in A level, which this is located as the chapter 8. Okay, this part will be quite long, so I will take maybe 2 videos to complete for the full course. Okay, for the first one, what we need to know is gravitational force. This gravitation for our Newton's second law of gravitational is state that 2 point mass attract each other with a force that is proportional to the product of their mass and inversely proportional to the square of their separation, where this is the formula and it must have a negative. Okay, what does this law mean? This means that for everything in the universe interval, whenever they have mass, for example, you have mass maybe 50 kilogram, and you are looking at your laptop have mass also maybe 1 kg. Okay, whenever two things in the universe they have mass, then they will have a attractive forces. Means there will be a force that attract you and your laptop to become closer and closer. So this is the Newton law of gravitational. However, why don't you feel the force, attractive force? Because let's see the formula. G is M1, M2 is the mass of both. Maybe the mass of you 50 kg, and M2 is the mass of your laptop, maybe 1 kg. Okay, R is the distance between M1 and M2, your distance. What is G? G is a gravitational constant. It's about 6.67 times 10 to the power of negative 11. So let's imagine if you just 50 kg and your laptop just 1 kg, 50 times 1 just equal to 50, and you multiply by this gravitational constant, the force you get will be very, very small until it is negligible. That's why you can't feel it. You cannot feel the attractive force between you and your laptop. However, this doesn't show that it doesn't exist. Okay, so the attractive force appear whenever they have two mass. Whenever something have mass, they will be attract. Okay, now I want to derive an equation between the velocity of this moon orbiting the earth. Okay, just recall back our circular motion. For something that you need to orbit something, you need to have a centripetal force. Okay, mv squared over r, centripetal force. And what does this centripetal force come from? This come from the gravitational force, G m m1 m2 over r squared. This time we neglect the negative term. Yeah, I forgot to tell you why is this negative term. Because for the law of gravitational, whenever two things have mass, they will attract each other. So for attractive force, there must be a negative. If I put a positive here, Gm1 m2 over r squared, this positive means that it is a repulsive force. It will push other away. However, this is wrong, because in our Newton's law of gravitational, two things must be attract to each other. So there must be a negative sign. Okay, let's go back here. So in here, I will neglect the negative term because we know that it must be a attractive force. We just neglect the direction because we know that the force is the same direction. Okay, so after that we will get mv squared over r squared equal mv squared over r, mv squared over r, mv squared over r, and g m1 m2 over r squared. So this m refer to m2. mv squared, remember F equal to ma, our free body moving diagram. This ma is said that the moon accelerate. So this is the mass of the moon. This is the mass of the moon. This is the gravitational attractive force. So after it cancel m2 and m2 cancel, square and r cancel, we will get our v is equal to g m1 over r square root. So this is our velocity of what? Of the moon when it is orbiting the earth. And remember, this velocity is referred to the linear velocity. Linear velocity when it's travel around the earth, means here or something here or somewhere here. This is the linear velocity, v equal to gm1 over r. Okay, next we're going to see about what is this. This is gravitational field strength. Okay, this gravitational field strength is given by G equal to F over m, just force per unit mass. Okay, so the equation just Gm over r squared. Okay, let's see what does this mean. Gravitational field strength. The units are n kg inverse. A vector quantity whose direction is given by the direction of the force a mass would experience if it is placed at the endpoint of interest. So this is the formula. Okay, I just give you some example. If I have something here, okay, this is a mass 1, this is a mass 2, this is a mass 3. We know that they will attract each other, they will attract each other, right? So if I want to find the resultant force, net force, I will have a force attract here, then I will somewhere have here. Okay, this is for the general equation. For gravitational field strength, you can regard as F equal to mg. Just remember our weight. People ask you how many kg have you have? Maybe 50 kg, but how many newton? Maybe 49 newton. Because this is, we talk about weight. Okay, weight. And remember, this weight is come from this G. This G, we always say that is 9.1, or sometimes we say that is 10.0. Okay, this G, every time we talk about this small g, is actually the gravitational field strength. So what does this mean? When this G is constant, actually it is not constant, but we assume that it is constant in all around our Earth. Okay, in all around our Earth for our easy calculating. But why is this G is constant? Means, what does this mean? Means that for every people, it stand on the Earth, it will experience a force, a G, gravitational field strength that is equal to 9.181. You can imagine that this gravitational field strength is our gravitational, the gravity, something at 9.81 or 10.0. And the total force is depend on how much mass you have. Okay, so this is actually a vector quantity. You can imagine that is a field. Okay, for someone to stand or stay in the field, they must experience something, and that is, they must experience this 9.81, the gravitational field. Okay, so I will stop here. If anything you don't understand, you hope I will explain it again, you can just leave a comment, then I will do another video for further explaining. Thank you.